Welcome, Travis Lawrence with Arrow ECS. Today's session is on NSX integration with vRealize automation. So today's session is a 201, so a deeper dive than some of our overview videos. Really, we're going to get into how you can leverage vRealize automation with NSX and software-defined networking. And I think what we've seen a lot in distribution from this is customers think, oh, well, this is for orchestration and automation, or cloud management platforms are really for those really large organizations that have tens of thousands of virtual machines, and there's no benefit to anyone smaller than that. And in this session, we're going to discuss why that is not the case, why orchestration and automation is not just for large organizations, where we can leverage this down to sort of medium-sized businesses, and that there's use cases for dev and test environments in addition to larger multi-tenancy environments. What we're really trying to do here is think of infrastructure in a programmatic way. So having programmatic infrastructure deployment or application deployment, including that networking piece, so including that NSX integration, and really being able to move away from having to do physical network changes. I mean, it's great that we can deploy a virtual machine, and we saw a ton of advancements from being able to not have to go through the procurement and hardware provisioning lifecycle for server infrastructure, but it is still, our application deployment doesn't mean a lot to the business if we have to slow down to deploy networking and storage pieces just as we had in that scenario. So what this session will really look at is how can we take those different types of scenarios and deploy logical switches, routers, and firewalls in software, and again, move away from those physical network changes and automate that and programmatically provision the entire application using an automation type software like vRealize automation. So we'll also touch on how do the new vRealize Automation 7 announcements simplify things like application deployment. How can we make this sort of a simple process using those blueprints? And ultimately, how do we utilize blueprints in VRA to deploy NSX and the security policies and simplify the whole operation? Things like on-demand micro-segmentation are also covered, so we can have security applied as VMs or even entire data centers are provisioned, again, via policy. So with that, I will pass it on to Kevin Grote, our VMware Technical Partner Manager. And as always, you can reach out to me at tlawrence@arrow.com or on Twitter @TLLawrence. Thanks again for joining us.
Hello, and welcome to today's session. As always, I'm your host, Kevin Grote, Technical Partner Manager here at VMware. And today, we're going to be talking about cloud automation and NSX integration and software-defined networking and how that fits into the cloud vision. Now, some may think that things like cloud automation and software-defined networking are really for the only most elite data centers out there. However, the ideas of automation have capabilities right down into our medium-sized data centers for integrations with things like dev, test, maybe even chargeback or multi-tenancy between divisions, groups, or departments inside of our corporations. And NSX, as we know, provides us the flexibility that we need to isolate secure networks, to micro-segment workloads from one another, to provide application-level security. So when we talk about integrating these ideas together, really we're seeing the foundational premise for security and scalability inside of our new multi-tenanted unified hybrid cloud. So today we're going to be looking at NSX's integrations with vRealize automation, and as an added benefit, we're going to be looking at some of the changes and announcements inside of vRealize Automation 7 that were announced at VMworld 2015 this year. Without any further ado, let's go ahead and get started taking a look at NSX integrations with vRealize Automation 7. So if we talk about the integration of NSX and vRealize automation, let's start with asking ourselves, why NSX? Well, why we would leverage NSX inside of this space is because we need to provide support for programmable application topology. So what does that mean? As we're looking at the application tiers that we deal with today. Here we have an example of a simple three-tiered application. We have a database, we have load-balanced application servers, and then we have some distributed web servers that are accessing them. And with NSX, we're able to provide logical switching, routing, firewalling, and load balancing between these systems. Again, and we talked about this in some of the other sessions, where we're able to protect the virtual machines using distributed firewalls so that they're protected from each other, as well as from attacks coming inbound and outbound. And we're able to provide that simplified switching inside of each one of these spaces. And we're able then to ensure that machines are able to route, and they're also able to communicate effectively through load balanced routing. And then we're able to firewall machines. Again, that could be at the group layer. It could also be from one virtual machine to another. And then we're also able to load balance, for example, inside of the web tier, to ensure that we have all of the effective communication and that we're not, creating any bottlenecks inside of the application stack. We can then apply security groups and security policies to the machines so that everything is being spun up effectively inside of the space. So maybe there's a default group that triggers a firewall for access to things like DNS and Active Directory, and it triggers an antivirus to scan every day. Then we may also have a standard web that's going to be applied inside of the web tier that's going to allow basic traffic. It's going to prevent DOS attacks and enforce acceptable use inside of the web tier, things that we wouldn't need inside of the database layer. And then in the app tier, maybe we have a standard application policy that gets applied to allow specific transactions to come in, so that we have one port coming in from web traffic and then an outbound into the SQL databases, and then a database policy that allows us to allow all inbound SQL and restrict anything coming back out, and maybe apply an additional security management for vulnerability inside of this space. So we can see we can create very detailed topologies, and we can do it all and leverage security groups and simplified access inside of this space that we would never really be able to execute at any scale. And this is one thing if we're talking about maybe just leveraging one single implementation. But as we know, when we start talking about cloud automation, that this one idea can be replicated multiple times, where we have tons of different tenants or groups or departments all wanting the exact same topology. NSX not only allows us to do what we see here, but to do it at great scale. So if we leverage NSX with vRealize Automation, formerly vCloud Automation Center, we're able to provide dynamic configuration of all of these logical services more effectively. So NSX brings us the capability to leverage logical switches, logical routers, logical firewalls, and logical load balancers. And with vRealize Automation, we're able to leverage service catalogs, multi-machine and single machine blueprints, as well as the security policies, groups, and network profiles that exist inside of that space, and reserve resources for specific groups. This means that we have on-demand application delivery, and we're able to do it at great scale. And we're able to repeat this as many times as necessary, whether it's across geographies, whether it's across divisions, groups inside of our infrastructures, and it's all going to be replicated faithfully, secured, and it's going to be super flexible and not require us to completely rip and replace our entire infrastructure to leverage it, because we're utilizing a lot of our existing resources and commoditizing it through software. So if we look at some of the network profiles that can be applied inside of vRealize Automation, so the network administrator is going to predefine the profile for connectivity. And then of course the cloud administrators are going to define the blueprints that are going to have the machines in them that will use those profiles. And then you can combine certain network types inside of a blueprint to ensure that machines can communicate in different ways. So there are really 4 core network profiles, either external only, routed from inside to outside, and vice versa, network address translation, or just a private isolated network. So, external would maybe look like this. So it's going to go, out to, any specific, upstream router, and we've got just external traffic focus. Routed will ensure that we have a logical router in place and that we're able to communicate with any upstream router, outside of our network. Network address translation, as we know, is going to ensure that the addresses are being translated through the logical router using a network address translation gateway so that we have predictable behavior for all of the network addresses. And then private would be, like I said, maybe like an isolated or a stub network of sorts where we can secure individual workloads from anything else. So this gives us a lot of flexibility in what we're able to do. And now with all of the announcements around vCloud Air, we now have not only this capability inside of the data center, but we have the same capabilities outside of the data center. And when we integrate this with what vRealize Automation is able to do, we can see that we can create entire networks repeatably that have any of these different profiles, maybe combinations of all of them, to ensure that maybe one workload that's private is communicating to a routed workload, or one workload that's leveraging NAT is communicating only to a private workload. And so it gives us a ton of flexibility in what we do and the way that we architect solutions and the way we're able to make those solutions highly repeatable. So security groups and security policies really just allow the end user and the cloud admin to select the security policy that the network admin is putting in place. So it's taking what the network admin builds that meets the SLA and the security policy of the infrastructure, and saying, when the cloud admin creates a blueprint for it, which policy do you want to apply to this group of machines? Or when the user selects workloads, that they can select how those network policies are going to be applied, if that's inside of the restrictions and capabilities for their role. And then all it does is create those security groups at the time that the machines are deployed. So this is a really important point, because we're not just deploying things whenever we, filling a vacuum of sorts and saying, okay, well, you need to create a huge policy and this broad sweeping change and all of these virtual machines and all these resources need to be allocated. It's creating these policies ad hoc when it needs them, so that the virtual machines are being provisioned with the resources they need. So really we're seeing the birth of a true on-demand network access and on-demand machinery accessing the network that it needs to be effective. And then those services, again, as we saw, maybe example, standard web. This means that when a user requests resources and they press the gimme button of sorts, then we're going to have machines that are getting spun up and having security policies applied to them. And then as those machines become deprovisioned, then the security policies stay there and wait for the next machine to get deployed. We can also leverage security tags to define if-then workflows. So let's just take a quick look at what that means. So we have, our application stack and our infrastructure space. So inside of our infrastructure space, maybe we have a finance policy security tag that says, if a tag equals finance, then add the virtual machine to a security group finance and secure it with security policy finance. So now we've got the security admin who's predefined a group and a policy with a dynamic membership based upon a tag. If the tag exists, then add it here and secure it this way. And inside of the app space, the cloud admin can create a multi-machine blueprint which sets a security tag. The cloud admin doesn't have to have any knowledge of the security group or the security policy because the security admin is doing it. The security admin builds a blueprint and just says set the tag to finance. And then when the machines get spun up, then it'll be added to the security group for finance and secured with the security policy for finance. And so that way we have true bicameral administration, allowing everybody to focus on the parts of their infrastructure that they know best. If we looked at another example, we take it a step further, the user is going to then request those resources via the service catalog, and then the virtual machine gets created, it gets protected because it had the finance tag, and then the virtual machine is dynamically assigned into that predefined security group and is protected accordingly. So in some of the previous videos, we looked at micro-segmentation and what this means to us. Everything from the simplicity of just being able to isolate communication paths between machines using VXLAN, to being able to leverage firewalls and routing so that virtual machines are only able to communicate with other virtual machines in the way that we're aligning them, all the way into advanced services utilization for things like Palo Alto Networks or McAfee or Rapid, so that we're able to see beyond just the networking stack into the actual operating system and protect the application itself. But now if we look at on-demand micro-segmentation, we can have different types of security being applied to the network as machines are being provisioned, or as maybe even entire data centers are being provisioned. Here we have no communication path. This may be an example of a private network profile. And segmentation through security policies that are being applied to those security groups and being built out by the security administrator, so that as tags are applied from the cloud admin, that machines are being placed and secured accordingly. And then to leverage advanced services inside of this space so that we're able to utilize things like Palo Alto, McAfee, Symantec inside of highly automated and repeatable virtual infrastructures. So we take a look again. We have virtual machines leveraging these logical switches, leveraging the logical routing and the firewalls that exist between them, and then the load balancing inside of that space, and then applying all of those security policies as needed based upon tags. With vRealize automation, in version 6, we had a lot of components that were required for deployment, but we've seen huge changes. Now, instead of having to have separate identity servers, separate data store appliances, separate orchestration appliances, we've seen points of integration where we've moved orchestration into being first class inside of the vRealize virtual appliance, so that orchestration of applications and orchestration of workloads is now a top priority, and it's inherent inside of the space. The same is true for the data stores. And bringing in identity, so we no longer have to integrate with additional single sign-on, and we can have clearer points of integration, brings us into version 7 of vRealize automation. So increased flexibility in deployment. We even have wizard-based deployment inside of this space. For more information, check out the video on the VMworld 2015 Barcelona announcements, where we talk more about what changed inside of vRealize automation version 7. One of my favorite things, though, is the unified blueprint model. And I think this is really important to talk about when we're talking about NSX, because NSX now plays a very, very big role inside of this. Because when somebody is designing a blueprint, the network now becomes a very clear part of the dependency network and security relationships that machines have. So we can look at a machine and the application that lives on the machine, and the dependencies that reside between applications, and the way machines connect to individual networks. And all of this can be programmatically defined inside of vRealize automation. And we now have the ability to provide nested multi-machine blueprints inside of this unified blueprint model and the design canvas. So when we're creating things with NSX, we now have that security integration inside of this space. And you can see some of the different types of things that we can create. We can leverage existing networks, existing security groups, or security tags that were defined, again, by the security admin. We can also create new on-demand network components, whether it's on-demand routed, private, or address translated networks, and be able to leverage all of those and ensure that the communication paths are set up inside of the blueprint so that we know what's connecting to what and how it's happening, and that we're also adhering to the dependencies that we've outlined within the application stack. So things won't communicate until it's time, and we're also able to secure communication right down to the application that's leveraging it. Why is this important? It's important because we have to be able to do this with a level of simplicity. If we consider that this is kind of what we're looking at today, we've got maybe a multi-machine blueprint that has security policies and databases and individual points of routed connectivity, speaking to other firewalls and other load balancers and other virtual machines inside of that space. We need to be able to replicate this with simplicity, ensuring that everything is communicating, and we're also able to provide access between the physical and virtual worlds that they're living within. So vRealize automation and NSX brings us to a space where we previously were only really leveraging the overlay in a real way. We're now leveraging the switching, the routing, firewalls, and load balancing strongly inside of vRealize automation, thus giving us the ability to create sophisticated topologies exactly the way we need them, and to be able to do it at scale with great simplicity. I want to thank you for taking time to join me today. As always, I hope you found value in these sessions. Be sure to subscribe to the channel, and also to follow me on social media for more updates and information regarding events, streaming roundtables, and more video content that continues to come out regarding these fantastic products. For more information, be sure to check with your local VMware engineering teams. And as always, have a fantastic day. I look forward to talking to you again soon.